One of the most fundamental decisions that firms' management has to make is what to charge. That's because firms are interested in making money. That's related to total revenue, which is price times quantity. If this entrepreneur, for example, sells 10 glasses of lemonade at 10 cents a glass, her total revenues are $1. Now, how could she increase revenue? You might think that if she increases the price to 25 cents a glass, revenues would go up. But because of the law of demand, customers may shy away from expensive lemonade, so total revenues could actually drop. On the other hand, she could take advantage of the law of demand by lowering the price and stimulate sales, so total revenues could go up. In this program, we're going to look at ways to compute numeric change. We'll continue our explorations of supply, demand, and the concept of elasticity.
Supply and demand helps us understand the behavior of firms and households and how they respond to change. We believe that when the price of a good or service increases, households will purchase less of it and firms will produce more of it. Well, sometimes we want to be more precise and to predict the magnitude of these changes, or at least understand how responsive demand or supply is to changes in economic variables. Elasticity is the measure of responsiveness that economists use. It's important to understand that there are many kinds of elasticities. In fact, there are as many kinds of elasticities as there are economic variables. The price elasticity of demand measures the sensitivity of demand to price. The income elasticity of demand tells us how responsive demand is to changes in income. And cross-price elasticities tell us about how demand changes when the prices of substitutes or complements change. Let's begin with price elasticity. Here's a diagram of two demand curves. Notice that the one on the left is drawn with a very shallow slope, and the one on the right is much steeper. Let's plot the quantity demanded for a given price on these two curves. Now let's see what happens when we lower the price and trace out the changes in the quantity demanded. As you can see, for the same change in price, the change in the quantity demanded for the schedule on the left is much greater than for the one on the right. So we say that the demand curve on the left is more price responsive, or exhibits a higher price elasticity. We can actually quantify these changes.
The segment you are about to watch contains numerous algebraic formulas. Viewer discretion is advised.
First, we note that our price fell from $5 to $4, which is a 20% decrease in price. Or algebraically, we have $4 minus $5 divided by $5, which is minus 0.2, which is our 20% decrease. For the demand schedule on the left, the quantity demanded increased from 50 to 75 units, which is a 50% increase in the quantity demanded. Or algebraically, we see 75 minus 50 divided by 50, which is 0.5, or a 50% increase. For the demand schedule on the right, the quantity demanded increased from 50 to 55 units, which is only a 10% increase in the quantity demanded. Algebraically, we see it as 55 minus 50 divided by 50, which is 0.1, or a 10% increase. The definition of price elasticity is simply the ratio of the percentage change in quantity demanded to the percentage change in the price. So for our first example, we compute the price elasticity by taking 50% divided by minus 20%, which is minus 2.5. In the second example, elasticity is computed as minus 0.5, which is 10 divided by minus 20. What elasticity tells us is that the first demand curve is 5 times more price responsive to changes than the second one, at least over the range that we computed. And since elasticity is a unit-free measure, we can compare price responsiveness regardless of the units. That makes elasticity a more valuable way of communicating the shape of the demand curve. When you're looking at economic data, how do you know if you should consider the price falling or rising? In our example from above, when the price went from $5 to $4, we computed a 20% decrease in price. If the price went from $4 to $5, then we would have a 25% increase. Well, we get around this difficulty by using average elasticities computed at the midpoint. Point elasticity measures the elasticity of a specific point on the demand curve. The formula is delta Q over Q divided by delta P over P. Remember, one fraction divided by another fraction is equivalent to multiplying the first fraction by the reciprocal of the second. So delta Q over delta P times P over Q is our formula for the elasticity. Recall that delta Q over delta P is the inverse of the slope of the demand curve. So the point elasticity of demand is 1 over the slope times P over Q. Well, let's take a simple example that shows the relationship between P, the price, Q, the quantity, total revenue, TR, and elasticity. Notice that over the elastic portion of the demand curve, well, that's where elasticity is greater than 1, if we increase price, total revenue falls. And if we lower the price, total revenue increases. Conversely, over the inelastic portion, if we increase price, total revenue rises. And if we lower the price, total revenue falls. Now, the second way of calculating elasticity is called the midpoint elasticity formula. In computing the midpoint elasticity, we want to know the elasticity over a range of prices. The formula for the midpoint elasticity is a little more complicated than for the point elasticity. The general definition again for elasticity is the percentage change in quantity demanded divided by the percentage change in price. For the midpoint elasticity, let's first calculate the percentage change in quantity. The formula is the change in quantity divided by the average quantity. For example, let's calculate the midpoint elasticity by lowering price from 10 to 8. The change in quantity is 2. The first quantity is 0, the second quantity is 2. Since we are calculating the average, we divide 2 into 2, which is 1. So the percent change in quantity demand is 2 over 1, which is 2%. Now let's calculate the percentage change in price. The change in price is 2. The first price is 10 and the second price is 8. Adding these together, we get 18. Well, since we're finding the average, we divide 2 into 18, which is 9. So the percent change in price is 2 over 9, which is 0.22%. Now let's combine them. 2% divided by 0.22% is 9. This means that for every 1% change in price, quantity demanded changes by 9%.
It's time once again for Smart Guy, Dumb Guy.
Elasticity, man. I don't get it.
What don't you get?
Well, I don't even know what this guy's doing. I know it has something to do with the slope of the demand curve.
Well, it's not a slope. It's like a slope.
Yeah, that's what I don't get.
Okay, here, look at it this way. Okay, see this E? Okay, draw it this way. That's perfectly elastic. And this I, that's perfectly inelastic.
Got it.
Okay, now, for regular straight line demand curves, you find the middle. Okay, above the middle is elastic, below the middle is inelastic.
But how do you find the middle?
Well, take either the vertical or horizontal axis and divide by 2. Okay, and then you draw the line, look like this.
Okay, but what if he actually wants me to calculate one?
That's easy. Use the formula. Okay, percentage change in quantity divided by percentage change in whatever.
Whatever?
Yeah, whatever's changing. Like prices or income, okay? So let's say we want to find the income elasticity, all right? If income goes up by, let's say, 10% and demand falls by 5%, the income elasticity is 1/2. 5 divided by 10.
Okay, I got that, but what about that weird formula?
Oh, yeah, okay. Let's say you have 2 prices and 2 quantities, and we'll compute the price elasticity. Okay? So, when the price is $6 and the quantity demanded is 5 units, and the price is $4 and the quantity demanded is 15 units, we do it like this. Okay, take 5 minus 15 divided by 5 plus 15. And divide the whole thing by 6 minus 4 divided by 6 plus 4. You just have to match up the right price and quantity.
But what comes first?
Look, it doesn't matter. Okay, just as long as the price, which is 5, matches the quantity, 10.
So what's the answer?
You figure it out from here.
Okay. I got minus 10 divided by 20 on the top.
That's called the numerator.
Yeah, well, I call it the top, okay? And in the bottom, I got 6 minus 4 divided by 10. That's,
Okay.
I mean, like 2 divided by 10.
Mm-hmm.
So now what?
Well, like, do it.
You mean do the math?
Look, okay, here's my calculator.
Okay. All right. Negative 10 over 20 divided by 2/10. Hey, that's like minus 100 over 40, like minus 2.5. Wow.
Exactly. Pretty elastic, huh?
Far out. Give me another one.
When we graph straight line demand curves, although the slope is constant, elasticity changes throughout. An easy way to figure this out is to bisect the linear demand curve. At the midpoint, elasticity is equal to 1. Above the midpoint, elasticity is greater than 1, and below the midpoint, elasticity is less than 1. Well, this can help us figure out the price where total revenues are a maximum. Remember that total revenue is equal to price times quantity. Now, holding everything else constant, if we increase the price, demand will go down. So P goes up and Q goes down. Similarly, if P goes down, Q will increase. So what will happen to total revenue? If we drop the price a little and quantity demanded increases a lot, which is a characteristic of high elasticity, then we would expect total revenue to go up. And if we drop the price a lot and demand doesn't change by very much, which is a situation of inelastic demand, then revenue should fall. If elasticity is greater than 1, then revenues increase when the price decreases because the quantity magnitude swamps the price effect. And on the other hand, if elasticity is less than 1, revenues will decline if prices decrease.
What do we do with this information? Let me go back to OPEC first. The Organization of Petroleum Exporting Countries, when they decided to cut exports, they were depending on the elasticity, on the price elasticity of demand to be very low, somewhere between a -1 and 0, see, which it was, and it still is. See. And so as a result of that, by raising prices, the quantity consumed did drop, but not by very much. See? And therefore they were able to bring in a tremendous amount of revenue from the sale of their petroleum. See? And of course they used this revenue for various things in terms of developing of the country and to purchase other goods from other countries. But in any case, they were depending on the price elasticity to be very low or inelastic. However, the thing that they overlooked was that in the long run, the price elasticity proved to be quite high, actually, somewhere in the neighborhood of -1.3, in other words, elastic. And as a result of that, there were tremendous conservation measures. In 1974 and thereon, automobiles were coming out with more fuel-efficient engines. So the miles per gallon of fuel increased tremendously in the next 5 to 6 years. And it still, of course, is increasing a little bit. People were conserving on the use of electricity, which was related to petroleum imports also. So there were these various efficiency moves that took place, and that resulted in a tremendous conservation or in other words, a tremendous reduction in the use of gasoline, all other factors being given. In other words, after you account for all other factors or variables, they may have changed.
Because of the law of demand, we know that when prices go up, demand will go down, and when prices go down, demand will go up. This means that the price elasticity of demand will always be a negative number. When the denominator is positive, the numerator will be negative and vice versa. Conventionally, economists generally ignore the negative sign of price elasticity. So if we read that the price elasticity of demand for cigarettes is 0.75, we know that if prices go up by 10%, then demand will decrease by 7.5%. Here's a table of estimated elasticities for several commodities. When elasticity is less than 1, the percentage change in demand is less than the percentage change in price, so demand is said to be non-responsive or demand is inelastic. When it's greater than 1, demand is price responsive or elastic, and if it's equal to 1, demand is called unitary elastic. Notice that eggs or gasoline show inelastic demand, while jewelry shows highly elastic demand. Well, why is this? Well, there are several reasons. First, if there are good substitutes for the commodity in question, people can find readily available substitutes if the price goes up, so elasticity would be high. If there are no good substitutes, then people have a difficult time finding alternative goods or services. In this sense, we expect the necessities to have low elasticity and luxury items to have a high elasticity. Secondly, if the price of a good represents a big portion of income, then price elasticity will be high. For example, if the price of something that costs a lot doubles, then people simply can't afford it. If the price is an insignificant part of income, then elasticity tends to be low. So if the price, for example, of salt doubles, demand isn't affected much at all. Third, time has a lot to do with elasticity in two ways. If price changes are thought to be temporary, then demand can be significantly affected. When items go on sale for just one day, people respond. If price changes are expected to be permanent, on the other hand, then people may be slow to adjust. In the short run, before consumers can adjust habits or find substitutes, elasticity is typically lower than it is in the long run. We'd say that the long run is a period of time when consumers have the time to adjust habits or buying patterns. An important example relates to the significant change in the price of gasoline in the early 1970s. When OPEC policy led to an increase in the price, consumers were somewhat stuck. Over time, however, these changes led to a big shift from large to small cars and drastically affected U.S. automakers. Empirical estimates show the short-run demand for gasoline is less than half the long-run demand for gasoline.
From a public policy perspective, the concept of elasticity is very important to understand the effects of taxes. Elasticity partly determines how much revenue the government will collect when a tax is imposed and who will ultimately bear the burden of taxation. To illustrate a tax, let's begin with a simple supply and demand model. When we tax cigarettes by 10 cents a pack, this shifts the supply curve vertically by the amount of the tax. The price consumers pay increases and the quantity demanded decreases. In this example, we've drawn the demand curve relatively inelastic. What this means is that the ultimate price of cigarettes goes up by close to 10 cents, which is the amount of the tax. So the tax was passed through to consumers. Contrast this with a tax on Swiss cheese, where the demand curve is more elastic. In this case, the same 10 cents per unit tax is shown, but because the demand curve is less steep, consumers react by substituting to other kinds of cheeses. In this case, although the price of Swiss cheese increases, consumers are able to find viable substitutes, and the tax is absorbed by producers. A nice example relates to a gasoline tax in Washington, D.C. in the late 1980s. In an attempt to increase the city's revenues, governments enacted a 6% increase in taxes, which pushed up the price of gasoline in the Washington, D.C. area. Because officials believed the elasticity of demand to be less than 1, they expected to earn substantial revenues. Fortunately for consumers, but not for the government, there was a perfect substitute for expensive Washington, D.C. gas right across the border in either Maryland or Virginia. So while the price of gasoline increased by 6%, there was over a 25% drop in sales, implying an elasticity of demand of over 4.
Why would decision makers in Utah be interested in the price elasticity of demand for gasoline? Well, probably the two most interested agencies are the Utah Department of Transportation and the Utah Tax Commission. Both of these work together in terms of the demand for gasoline and its impact on the amount of taxes that the state takes in from the sale of gasoline. Each gallon of gasoline today, for example, has a 19 cents per gallon tax that goes to the state of Utah, and it has presently a 18.3 cents per gallon tax that goes to the federal government. Both of these tax monies go into what is called a highway trust fund, and of course that highway trust fund is used to make road repair and to construct new highways.
Price elasticity is the most commonly talked about and researched measure because we think of demand as closely related to price. But anything that can shift a demand curve also has an associated elasticity. Income elasticity measures the responsiveness of demand to changes in income. It's defined as the percent change in the quantity demanded divided by the percent change in income. For what are called normal goods, this ratio is positive. So when income goes up, demand goes up. Inferior goods are those for which income elasticity is actually negative. So increases in income are associated with decreases in demand. When goods are related to each other as either complements or substitutes, price changes in one good leads to a change in demand for the other. For example, when goods are substitutes, an increase in the price of one leads to an increase in the demand for the other. These effects are captured by cross-price elasticities. They're measured by the percentage change in demand for one good and divided by the percentage change in the price of the other. Like with income elasticities, cross-price elasticities can be negative or positive, so we have to keep track of the algebraic sign of the ratio. For substitutes, it's positive, and for complementary goods, the sign is negative. If goods are independent or neutral, the sign is 0. For example, Girl Scout cookies and milk seem to go together. If the price of cookies goes down, I'll buy more of them and also more milk. Let's say the price drops by 10%. If my demand for milk increases by 10%, then the cross-price elasticity is -1. Remember, the price fell, which is a negative, and the demand increased, which is a positive. Now, what's a substitute for cookies? Well, how about brownies? If the price of brownies goes up, my demand for cookies goes up too. Why? Well, that's because I switched my dessert to the relatively cheaper one. Notice again that with substitutes, the cross-price elasticity has a positive sign. Elasticity, although sort of a strange word, is one of the most important concepts in applied economics. The measure summarizes a lot of information about the relationship between economic variables. Price elasticity tells us about the relationship between demand and price. And because of the law of demand, the relationship is always negative, so economists usually ignore the sign. Income elasticity relates demand to income. If the sign is positive, the good or service is normal. And if the sign is negative, then we're talking about an inferior good. Finally, cross-price elasticities measure the effects between substitutes and complements. If the sign is negative, then the commodities are complements. And if the price of one goes down, the demand for the other goes up. And if the cross-price elasticity is positive, then the commodities are substitutes. Neutral goods have cross-price elasticities near 0. Okay, we know the concept of elasticity is important, so how do we figure them out? That's the part of the topic of econometrics, which is statistical measurement in economics. We'll preview econometrics in our next segment, so stay tuned.
Chris, do you know the price elasticity of the demand for lemonade?